Hello everyone. Today we will be solving the last problem in today's weekly contest, and that is height of binary tree after subtree removal queries. So in this problem we will be given a binary tree and each node having unique value between 1 to n, and we will also be asked to perform m number of queries. Each of these queries are independent, and in the ith query we'll be given a particular node. We need to detach that subtree from the entire tree and then compute the height of the resultant tree. For example, in this problem, we are given that 4 has to be detached. So after detaching 4, we get this tree, and the height of the resultant tree is 2. Similarly, in this case, if we are asked to detach node 2, let's say, so after detaching 2, we'll be having only 5, 8, 9, 1, 3, and 7. And in that case, height would be 2. So these are the constraints. The number of nodes can go up to till 10 to the power 5. So a solution having complexity of big of n or big of n log n should work. So there are two approaches to solve this problem. The first approach is using Euler Tour tree flattening technique. Euler Tour. So those of you are not familiar with Euler Tour, what Euler Tour does is it stores the entry and exit time of each node. So this is easy to compute. Say we have, let's say, okay. Say we have a tree such as 1, then 2, then 3, then 4, then 5. So what entry and exit time means is while doing the DFS, at what point we like encounter a particular node. So the at first we call the DFS from root node. So the entry time would be 1. We then go to its child 2. Its entry time would be 2. We then go to its child 3. Its entry time would be 3. Now, since 3 has no more children, so it has to backtrack to its parent. So while backtracking, we mark the exit time, which is 4. In case of 2, it has one more child, so it will go to its child 4. So its entry time would be 5. Since 4 has no more children, its exit time will be 6. Now 2 has exhausted all its children, exploring all its children. So its exit time would be 7. 1 has still one more child to explore. So its entry time would be 8. And since 5 has no more children, its exit time will be 9. And since 1 has completed its entire search, so its exit time will be 10. So for each time, we marked which node was encountered. So let's create an array of size 10. At time 1, we got node 1. At time 2, node 2. At time 3, 3. At time 4, also 3. At time 5, 4. And 6, 4. And at time 7, we got 2. Time 8 and 9, 5, then 1. So if we clearly observe, let's say, let's take an example of 2. Its entry and exit time are 2 and 7 respectively. So this this range. So if you clearly see in this subarray, every node which occurs in the subtree of 2 are present. That is 2, 3, 4, 2, 3, and 4. These are the nodes. So what we can do is, how can we use this information to solve our problem? So we can also obviously store the depth from the root node for every node. We can store the height, the distance that it is from the root node. This is a simple DFS. While doing this DFS, we can also store the in and out time as discussed in the example. So now that we have the in time, out time, and the level, so whenever we get a particular query, let's say we have this graph, this tree. Say we need to detach this node from the entire tree. How can we use this information? While if we detach this node, what is the range that we have? Initially, we had its in time was 1 and its out time was lay OT. So if we detach this, so this node must have as an in time of 1, in time of IT and OT1. So if we while flattening the tree, we saw that an entire subtree can be represented as a subarray. So after removing this entire subarray, our main motive is to find the maximum in the remaining array, right? So maximum of height. So if we clearly check, If we clearly check that after removing this subarray, what is the height or maximum depth from the root node of the remaining nodes, this will be our answer. So computing the range maximum can be very easy. We don't need to use any specific or complicated data structure such as segment tree or sparse table. All we can do is our main problem has reduced to we have an array. Out of this, in every query, we need to remove a subarray, and then we need to find what is the maximum in the remaining range. So what we can do is we can store prefix maximum and suffix maximum. After removing this subarray, this, let's say this has an index of L, this has an index of R. We need to return the maximum of max of prefix max of L and suffix max of R. This will be the result for a single query. So this is an approach. If we check the code, so initially I maintained four unordered maps, which would store the in time, out time, the flattened tree, and the height of each of the respective nodes, and one unordered map to store the adjacency list. So initially I call the DFS. Whenever I get a root node is null, we can simply return. Else we store its height and then create the adjacency list. If a particular node has its left and right child, so we can push it to the adjacency list of that particular node, and then we recursively call the DFS for the left and right child simultaneously, and then we flatten the tree. So in this part we can easily see that the in time is marked, and then here we enter at what time this node was entered. Then we recursively call the Euler Tour function for each of its children, and then we mark the exit time, and then the flatten tree for that at what time which node exited at a particular time. So after this is done, all we need to do is to create a prefix max and suffix max. This is fairly easy. Then we iterate from 1 till timer, and then we compute the prefix max. Similarly for the suffix max as well. Now coming to solving the queries part. For each particular query, we take the in time at that particular at what time this node entered and at what time this node exited. So these are the in time and out time of a particular node. So by Euler 2, we know that this in time and out time represents the entire subtree. Since we need to remove the subtree, so our range becomes from 1 till in time -1 and out time +1 up till the timer, the max value of timer that it took to explore the entire tree. So we need to find the maximum in this range, and we need to push it back to our result vector, and we can finally return our result. So in this way we can solve this problem. The time complexity for this problem will be each of the DFS and Euler tool takes big O of n time, and solving this computing this prefix and suffix max takes big O of 2n time, because timer can go up till at max of twice of n, and the solving this query will be big O of q, and we compute each query in order of 1 time. So yeah, this is the solution. Thank you for watching. Hope you like the video.